Hello guys, welcome to the GC4 YouTube channel. It's another video correcting past GCE questions, and today we'll be doing the correction of the Cameroon GCE Ordinary Level Additional Mathematics Paper 1 of the year 2025. So let's begin. Question 1, we have 1/3 raised to the power negative 1 is the same as a number raised to the power negative 1 is 1 on the number, 1 on 1/3 is equal to 3. So we have C as the answer of question 1. Question 2, log P on Q is equal to, from the laws of logarithm, this is equal to A log P minus log Q. Question 3, 1 plus 3 root 2 times 1 minus 3 root 2 is equal to, looking at this expression, this is a factored out version of the difference of two squares. So this is the same as 1 squared minus 3 root 2 squared. So this would be, this is the same as this, and 1 squared is equal to 1 minus 3 root 2 squared. We have 3 squared which is 9 and root 2 squared which is 2. 9 times 2 is 18, so we have 1 minus 18 which is equal to minus 17. And looking at the options, you have minus 17 which is B for question 3. Now question 4, the sum of roots of the quadratic equation bx squared minus cx plus a is equal to 0, where b is not equal to 0 is, the sum of roots of a quadratic equation is equal to the negative of the coefficient of the x term all over the coefficient of the x squared term. In this case, the coefficient of the x term is negative c, negative c is c all over b. So we have A for question 4. Now question 5, given that x minus 2 is a factor of the polynomial x cubed minus kx squared minus 5x plus 10, the value of k is, now if x minus 2 is a factor of this polynomial, then when x is equal to 2, f of 2 should be equal to 0. So this is our polynomial, and you know that f of 2 is equal to 0. Substituting 2 everywhere we find x, we have 2 cubed is equal to 8 minus 2 squared is equal to 4, we have 4k minus 2 times 5 is equal to 10, finally plus 10. This should be equal to 0. Now minus 10 plus 10 is equal to 0, we are left with 8 minus 4k is equal to 0. If you isolate the k, we are left with minus 4k is equal to minus 8, and dividing all through by minus 4, we have k is equal to 2. And looking at the options, we have k is equal to 2, which is B for question 5. Now question 6, the value of p for which the quadratic equation x squared minus px plus 16 is equal to 0 has equal roots is, for the roots of a quadratic equation to be equal, then its discriminant, which is b squared minus 4ac, has to be equal to 0. As said, for the quadratic, the roots to be equal, then its discriminant, which is b squared minus 4ac, has to be equal to 0. Looking at our quadratic equation, our b is negative p, and our a is 1, our c is 16. So b squared is going to be p squared, and our a is 1, our c is 16. 1 times 16 is 16, so we have 4 times 16 is equal to 0. 4 times 16 is equal to 24, so this boils down to p squared minus 64 is equal to 0. Now from here, if you isolate p, we are going to get p squared is equal to 64. Taking square root of both sides, we get p is equal to 8. And looking at the options, you have A for question 6. Question 7, the value of k when the polynomial x cubed plus kx squared minus 3x plus 1 is divisible by x minus 1 is, if this polynomial is divisible by x minus 1, it means when x is equal to 1, f of x should be equal to 0. Now this is our polynomial, and we know that when f of 1 is equal to 0, substituting 1 everywhere we find x, we have 1 plus k minus 3 plus 1 should be equal to 0. Now 1 plus 1 is 2, minus 3 plus 2 is minus 1. We have k minus 1 is equal to 0, k is equal to 1 at the value of k for question 7, which is B. Question 8, given that f of x is equal to x cubed plus 2x squared minus x minus 2, the remainder when f of x is divided by x minus 2 is, we can solve this using the remainder theorem. And that is, you have our polynomial, which is this, and we're dividing by x minus 2, that means x is equal to 2. Now substituting x is equal to 2 into this polynomial, we get 2 cubed is equal to 8 plus 2 squared is equal to 4 times 2. We have 8 minus 2 minus 2. This is equal to 8 plus 8 is 16. 16 minus 2 is 14. 14 minus 2 is 12. So our remainder is 12. The answer is 12 for question 8, which is D. Question 9. Given that Tn, which is equal to negative 1 to the power n minus 1 times 3 raised to the power n, is the nth term of the sequence, then T2 is equal to solve this, you substitute 2 everywhere we find n. So here we find that negative 1 raised to the power 2 minus 1 is 1, negative 1 raised to the power 1 is negative 1, times 3 raised to the power 2 is 9. So we have 9 times negative 1, which is negative 9, and D for answer of question 9. Question 10. The geometric mean of 1 and 4 or 9 is equal to. The geometric mean of two numbers is equal to the square root of their product. That is, the geometric mean of 1 and 4 or 9 is equal to the square root of 1 times 4 or 9, which is equal to the square root of 4 or 9. The square root of 4 or 9 is equal to 2 and 3, which is A for question 10. Now question 11. Given that the fourth term of an arithmetic progression is 12, with first term negative 3, the value of the common difference is. To solve this, you know that the expression of the nth term of an arithmetic progression is equal to this, where A is equal to the first term. In this case, we are dealing with the fourth term, which is 12. And we know our first term is negative 3 plus the nth is equal to, we are dealing with the fourth term, minus 1 times the common difference, which we are finding for an easy. Now this is equal to 12 is equal to minus 3 plus 3d. If you isolate the d by sending 3 the other way, we have 3 plus 12 is equal to 15 is equal to 3d. And we divide all 3 by 3 to get d is equal to 5. And that's the answer for question 11, which is C. Now question 12. Given that the sum to infinity of a geometric progression with common ratio 1/3 is 9, the first term is. To do that, we have the sum to infinity of a geometric progression is equal to this, where A is the first term and R is the common difference. Now from the question, we have the common difference, the common ratio is 1/3 and the sum to infinity is 9. So here we have that 9 is equal to, the first term is what we are looking for, and our common ratio is 1/3. From here, we have 1 minus 1 on 3 is 2 on 3. We have A divided by 2 on 3, that's 3 on 2A. 9 is equal to 3A on 2. And here, if we cross multiply, we get 18 is equal to 3A. And finally, A is equal to 6. That's our first term. And looking at our options, we have B for question 12. Question 13. The number of terms in the binomial expansion of 1 plus 3x raised to the power 9 is. The number of terms in such a binomial expansion is given by the power plus 1. The power here is 9. 9 plus 1 is 10. So for question 13, you have the answer B. Question 14. The first three terms of the binomial expansion of 1 plus x raised to the power minus 2 are. The first three terms of that binomial expansion is given by this. And from here, we have our binomial expansion being 1 plus x raised to the power negative 2. So our n is negative 2. And substituting those values in this formula, we have this. First is n, the second is negative 2x, and the third is negative 2 times negative 2 minus 1 on 2 factorial x squared. So from here, we have 1 minus 2x, 1 minus 2x, then negative 2 times negative 2 minus 1 is equal to negative 3. Negative 2 times negative 3 is equal to 6. 6 divided by 2 is equal to 3, and that gives us with plus 3x squared. And this answer corresponds to 1 minus x squared plus 3x squared b for question 14. Now question 15, the number of ways in which the letters of the word corona can be arranged is: corona, we have 6 letters and we see that the letter O repeats twice. So the number of ways to arrange the letter is going to be 6 factorial over 2 factorial, since one letter repeats itself twice. So here we have B as the answer for question 15. Question 16, in how many ways can 2 boys be selected from a class of 5 boys? This has to do with combination, and the formula for combination, we have this, where n is equal to the number of items. You have number of items, you have 5, and you are selecting 2 boys, so we are selecting R, we have 2, and substituting these values in this formula, Rn is 5, R is 2, N is 5, and the R is 2. Now this is equal to 5 factorial all over 5 minus 2 is 3, that's 2 factorial times 3 factorial times 3 factorial. And you can proceed here by expanding the 5 factorial in order to cancel out terms. So this can be 5 factorial is equal to 5 times 4 times 3 factorial. And from here you see that this 3 factorial can cancel with the 3 factorial below, and you're left with 5 times 4, and we're left with 5 times 4 all over 2 factorial, and 5 times 4 is 20, 20 on 2, we have 10 ways as the answer for question 6. So we have 10, which is D. Question 17, the quadrants in which tan x is positive are. To answer this, you can use the mnemonic all students take calculus. And you can shorten this as all students take calculus, where each letter stands for a quadrant, like A is the first quadrant, second quadrant, third quadrant, fourth quadrant, and A stands for all, like all the trigonometric identities, sine, tan, and cos. S stands for sine, T stands for tan, and C stands for cos. So we get that in the first quadrant, sine, tan, and cos are all positive. In the second quadrant, only sine is positive. In the third quadrant, only tan is positive. And in the fourth quadrant, only cos is positive. Now the quadrants in which tan is positive, that's you're going to have the first quadrant since it's all, and the third quadrant since where that's where tan is positive. So answer this question, you have the first and third quadrant, which is C for question 17. Question 18, 1 minus 2 sine square x is the same as. To solve this, we need to know there are 2 trigonometric identities. The first one is the double angle identity of cos, which states that for 2 angles A and B, cos A and B is equal to cos A cos B minus sin A sin B. In this case, since we are dealing with both angles which are the same and which are x, we have cos x plus x, which is 2x, is equal to cos A cos B, which is cos x equal to cos square x, and sin x is equal to sin square x. Now this is our first angle identity. This is our first identity. We move to the second identity, which is the Pythagorean identity, which says that cos square x plus sin square x is equal to 1. Alright, from here we can understand that cos square x is equal to 1 minus sin square x. And now if you substitute this value of sin square x back into this double angle identity equation, we have that 1 minus sin square x minus sin square x is equal to cos 2x. Now this equals that cos 2x is equal to 1 minus 2 sine square x, and this is the identity of cos 2x, 1 minus 2 sine square x, And looking at our options, we have that 1 minus 2 sine square is equal to cos 2x, which is B for question 18. Okay. Question 19, the exact value of sine 120 degrees is. To do this, we need to understand that 120 degrees exists in the second quadrant of the Cartesian plane. By that I mean, take for example, this is a Cartesian plane, and we have our first quadrant here, our second quadrant, our third quadrant, and our fourth quadrant. The first quadrant starts from 0 to 90 degrees, the second from 90 to 180, the third from 180 to 270, and the fourth from 270 to 360 degrees. Now in the first quadrant, an angle alpha in this first quadrant is simply equal to the reference angle, let's call it theta. In the case of this equation, question, our reference angle is equal to 120, that is, our theta is 120. Now in the second quadrant, an angle alpha is equal to 180 minus the reference angle, that's minus theta. In the third quadrant, the angle alpha is equal to negative 180 degrees minus theta. And in the fourth quadrant, the angle alpha is equal to negative the reference angle, which is theta. So now, since we are dealing with the second quadrant, the angle alpha is going to be equal to 180 degrees minus our reference angle, which is 120. In this case, our angle alpha is going to be equal to 180 minus 120, which is equal to 60. Now, as we earlier said here, in the second quadrant, you have sine, which is positive. So sine 120 degree is equal to sine 60 degrees, that's positive sine 60 degrees. From here we can proceed. Knowing that 60 is a standard angle, you should easily know the value, and if you don't know how to easily find the trigonometric values of standard angle identities, I will post a short explaining that. So the value of sine 60 is equal to root 3 on 2, which corresponds to the answer C for question 19. Now question 20, the length of the minor arc AB that subtends an angle theta at the center of a circle with radius r is given as, the answer of this is A, which is r theta. Question 21, the maximum value of y is equal to 3 sine x is the same as. To solve that, first of all, know that sine x exists between the range -1 less than or equal to sine x, which is less than or equal to 1. Sine x exists in this range. Now for sine 3x, we simply multiply the range by 3, and this boils down to -3 is less than or equal to 3 sine x, which is less than or equal to 3. And the maximum value in this range is 3, so the answer for question 21 is 3, which is A. Question 22, from the diagram, the side A is equal to, we can solve this using the sine rule, which says a side all over its opposite angle in a triangle is equal to another side all over its opposite angle, which is equal to the third side all over its opposite angle. In this case, we can start by using the side A and B, which from the sine rule we get the side A all over sine 30 is equal to B all over sine 70. So we have A on sine 30 is equal to B is equal to B on sine 70. Now from here we can cross multiply to find the value of B, and this is equal to B sine 30 on sine 70. Hence A is equal to B sine 30 on sine 70, and this value corresponds to A. A is equal to B sine 30 on sine 70 for question 22. Now question 23, the points P and Q have coordinates 4, 2 and 6, -4 respectively. The coordinates of the midpoints of P and Q is, so find the midpoint by summing the x coordinates divided by 2, the y coordinates divided by 2. So 4 plus 6 is equal to 10, 10 divided by 2 is equal to 5. Now 2 plus -4 is equal to -2, -2 divided by -2 is equal to 1. So the coordinate of their midpoint is equal to 5, -1, which is C for question 23. Question 22. The tangent of the acute angle between the line y is equal to 3x plus 2 and the x-axis is. The tangent of an acute angle between a line and the x-axis is equal to the absolute value of its gradient. In this line, you find the gradient is equal to 3. So the absolute value of 3 is 3, and hence that's the angle, that's the tangent of the acute angle between that line and the x-axis. So you have 3 for question 24, which is B. Now question 25. The equation of the line which is parallel to 2x minus y is equal to 3 and passing through the point 1, 0 is. To solve this, first of all, to put the equation of this line in the form y is equal to mx plus c. So we have 2x minus y is equal to 3. So we have 2x minus y is equal to 3. Putting that in the form y is equal to mx plus c, we have minus y is equal to minus 2x plus 3. Dividing all through by negative, you have y is equal to 2x minus 3. From here, we find out that our gradient is equal to 2. And since the lines are parallel, the gradients are going to be the same. So that the gradient of the second line we're trying to find is equal to 2 as well. Now, the second part of the question says, the line passes through the point 1, 0. We can solve this by using the general equation of the line, which states y minus y0 is equal to the gradient into x minus x0, where our y0 and x0 are the points through which the line passes. Now our x0 is equal to 1 and our y0 is equal to 0. So we have y minus 0, which is y, is equal to, the gradient is 2 into x minus our x0 is 1. From here we get y is equal to 2x minus 2. This is the equation of the second line. This is the equation of the line which is parallel to the line y is equal to 2x minus 3 and passes through the point 1 and 0. So we have 2x minus 2, which is equal to B for question 25. Now question 26. The perpendicular distance from the point 2, minus 4 to the line 4x minus 3y is equal to 0 is. Now the perpendicular distance between a point and a line is given by d is equal to ax plus bx plus by plus c all over a plus b, where a is equal to the coefficient of x, b is equal to the coefficient of y, and c is equal to the coefficient of z. In this case, there is no coefficient of z, so we're dealing just with a and b. And our a is equal to 4, our b is equal to minus 3, and our x is equal to 2, our y is equal to minus 4. To substitute all that in this equation, you have a is equal to 4 times our x is equal to 2, that's times 2. Our b is equal to minus 3, and our y is equal to minus 4, and c, the value of c is 0, so we can just eliminate that. Now coming down here, we have a which is 4, and you have b which is 3. This is equal to 4 times 2 is equal to 8. 8 plus 3 minus 3 times minus 5 is equal to 12. 8 plus 12 is equal to 20. And the square root of 4 squared plus 3 squared. 4 squared is 16, 3 squared is 9, 16 plus 9, 25. The square root of 25, you have 5. 20 divided by 5, you have 4. And that is the perpendicular distance between that point and the line. Looking at our answers, 4, we have C for question 26. Question 27. The range of values of x for which minus 5 is less than 1 minus 3x which is less than or equal to 4 is. So we have minus minus 5 which is less than 1 minus 3x, which is less than or equal to 4. So from here we have to try to isolate the x, and you can do that by, you can start by minusing 1 from both sides of the inequality. So we have minus 5 minus 1 is going to be minus 6, and the minus 4 minus 1 you have 3, and we have subtracted 1, so this no longer exists. And we proceed by dividing all through by minus 3. Now this boils down to minus 6 divided by minus 3, we have positive 2, and since we divided all through by a negative, the sign is going to change, and negative 3 divided by negative 3 is 1. Now finally 3 divided by negative 3, we have negative 1, and as we divided by a negative sign, the sign will change to this. So now the range of values of x for which this inequality holds, we have negative 1, which is less than or equal to x, which is less than 2. This is the range, and looking at the answers, we have negative 1, which is less than or equal to x, which is less than 2. The answer of question 27, we have D. Now question 28, the range of values of x for which 2x plus 1 times x minus 2 is greater than 0 is. From this, we have our two zeros, which are 2x plus 1 and x minus 2. We start by solving them independently. We have 2x minus 1. You can say let this be equal to 0, and let x minus 2 be equal to 0. We do this to get our two cutoff points. And solving the first part of the inequality, we have 2x minus 1 is equal to 0. If we send 1 the other way and divide all through by x, we have x is equal to 1 on 2. Now for the second x, we have x is equal to 2. And we can proceed by drawing a number line to find the range of values of x which are greater than 0. Now to do that, let's say this is our number line, and our first cutoff point we had negative half, negative 1 on 2. You can put that here, and our second cutoff point we had 2. Now taking any value below negative half, let's say negative 1, and substituting that in this equation, in this inequality, 2 times negative 1 is negative 2, negative 2 plus 1 is negative 1. Now here we have negative 2 minus 1, you have negative 3. Negative 1 times negative 3, we have positive 3, which is greater than 0. So values below negative half satisfy that inequality. Now values between negative half and 2, let's take for example 1. Substituting 1 in this inequality, we have 2 times 1 is 2, 2 plus 1 is 3. Now 1 minus 2 is equal to minus 1. 3 times minus 1 gives us minus 3, which is less than 0. So values here do not satisfy the inequality. Now taking values higher than 2, let's say 3. Substituting 3 in this equation, we have 2 times 3, which is 6. 6 plus 1 is 7. Now here we have 3 minus 2, we have 1. 7 times 1 is 7, which is greater than 0. So values above 2 satisfy this inequality. So the values which satisfy the inequality should be x being less than negative half and x being greater than 2. And looking at our possible answers, we have x being less than negative half and x being greater than 2. So we have D for question 8. Now question 28. Now question 29. The values of x for which the absolute value of 2x minus 5 is equal to 7 are. So to solve this, we have to understand that if we are dealing with the absolute value of 2x minus 5 being equal to 7, it means that negative 2x minus 5 should be equal to 7, and 2x minus 5 should be equal to 7. So to do that, we have the absolute value of 2x minus 5 is equal to 7. First of all, there are two possible ways of doing this. Either you square both sides to remove the absolute value sign, or you understand that the negative of what's in the absolute value sign should be equal to this, and the positive should be equal to this. Now using the first method, we have positive. Let's start with positive 2 minus 5 being equal to 7. We have 2x minus 5 should be equal to 7. We send 5 the other way. We have 2x is equal to 12. 2x is equal to 12, and finally x is equal to 6. That's our first value for x. Now we continue with the negative of what's in the absolute value sign. We have negative 2x plus 5 should be equal to 7. Now if we send 5 this other way, we have negative 2x is equal to 2, and we have x is equal to negative 1. Now these are the possible values of x. So we have the values of x, which are these. We have negative 1 and 6, which is negative 1 and 6, which is A for question 29. Now question 30. C went to a shop and bought X pencils at 100 francs and Y decides at 300 francs each. Given that the maximum amount of money she spent was on 1,200 francs, the inequality satisfying her expenditure is. So she bought X pencils at 100 francs. That's going to be 100 X, and Y exercise was at 300 francs plus 300 Y. And now given that the maximum amount she spent was 1,200, that means the sum of these should be less than or equal to 1,200, since this was the maximum she spent. Now we can proceed by dividing all through by 100 to get x plus 3y is less than or equal to 12. So this is the inequality satisfying our expenditure. We have x plus 3y is less than or equal to 12. B for question 30. Question 31. The statement x is at most thrice y and y is less than half of x is represented by the inequalities. X is at most thrice y means x is less than or equal to 3y. So that's x is less than or equal to 3y. And y is less than half of x, so y is less than x on 2, or we can cross multiply to have 2y is less than x. So x is less than 3y and 2y is less than x, which is B for question 31. Now 32. Given that the functions f and g are defined by f of x is equal to x minus 3 and g of x is equal to x squared minus 1, f of g of x is equal to. So for this we are substituting g of x where we find x in f of x. So our g of x equals to x squared minus 1. So we have x squared minus 1 minus 3 minus 3. So this is our f of g of x, which is equal to x squared minus 4. That's x squared minus 4. This is our f of g of x. And looking at the possible answers, we have B for question 32. Now question 33. The function f is defined by this. That's 1 minus 2x for x being greater than 0 and 3x for x being less than or equal to 0. Then f of negative 2 is equal to. First of all, we have to understand that negative 2 exists in the range x being less than or equal to 0. So we are substituting negative 2 into the f of x for f of x being equal to 3x. Now substituting negative 2 where we find x, we have 3 times negative 2, which is equal to negative 6. So question 33, we have B, negative 6. Then question 34, the function f is defined by f of x being equal to 3x plus 2. Then f inverse of 11 is. To start, you have to find f inverse. Now f of x equals to 3x plus 2. F of x is equal to 3x plus 2. Now f inverse, to find f inverse, we can start by saying let f of x be equal to say y. Then you have that 3x plus 2 is equal to y. From here we have to isolate the x, so we can send to the other way. We have y minus 2 is equal to 3x. We divide all through by x. We have y minus 2 all over 3 is equal to x. We can end by replacing y with x. We get x minus 2 all over 3, and this is the inverse of f of x. Let's call this f prime of x is equal to this. Now I was looking for f inverse of 11, so I was substituting 11 where we find x. So this is going to be equal to 11 minus 2. We have 11 minus 2, which is equal to 9. 9 divided by 3 is equal to 3. And that's the value of f inverse of 11, 3, which is C. Question 35. A linear transformation T is defined by T which maps xy up onto x minus 2y and y. The 2 by 2 matrix representing T is. Now, we have to understand that this mapping is the mapping with the basis of 1, 0, and 0, 1. So the basis of this transformation is equal to first base you have 1 and 0, and the second base you have 0 and 1. Now we're going to use the first base and substitute the value of the first base into this transformation to find the first column of the transformation matrix, then use the second base to find the second column. So for our transformation matrix, you have our x being 1 and our y being 0. X 1 minus 0 is equal to 1. And y is 0, so that's 1, and down here we have 0. Now for the second column of this transformation, we have our x is equal to 0 and our y is equal to 1. So 0 minus 2 is equal to minus 2. And then for the second part, our y is equal to 1, so I have minus 2 on 1. So this is the transformation matrix T. And looking at the options, you have 1 minus 2, 0, 1. We have B as the correct option for the transformation matrix. 3, 2, 5. Question 36. Given that the matrix M, which is equal to 3, 2, 5, 4, the determinant of 2M is equal to. So M is equal to 3, 2, 5, 4. 2M is equal to 3 times 2 is equal to 6, 5 times 2 is equal to 10, 4 times 2 is equal to 8, and 2 times 2 is equal to 4. Now the determinant of this is going to be 6 times 8, which is 42, minus 4 times 10, which is 40. This is equal to 2, and that's the determinant of 2M. We have 2, which is A for question 36. Now question 37. An invariant line under this transformation T defined by the matrix 2, minus 1, minus 1, 2 is. Now an invariant line is a line which, when transformed by a matrix, all points on the line remains the same. Now to do this, we can do try and error for each line in the option. Our first line is x plus y being equal to 0. So we have the first line, x plus y is equal to 0. We have to start by putting this line in the form 1. We have y is equal to negative x. Now from here we take an arbitrary point on the line. Let's say when x is equal to say 1, y is equal to negative 1. So our first point, we have 1, negative 1. Then we proceed by transforming this point on the line by this transformation matrix. Our transformation matrix is 2 minus 1 minus 1, 2. So we have 2 minus 1 minus 1, 2. This is our transformation matrix, and we are going to multiply this by the point on the line, which is 1, minus 1. Alright, so 2 times 1 is equal to 2, plus 1 times minus 1 times minus 1, which is equal to 1. 2 plus 1 is equal to 3. And finally, minus 1 times 1 is equal to minus 1. 2 times minus 1 is equal to minus 2. Minus 1 minus 2 is equal to minus 3. So this is, the line is almost the same, because this is the same as 3 into 1 minus 1. So this line can be considered invariant, but we have to continue by doing the other lines for quantification. Now the second line, we have 2x minus y, which is equal to 0. Putting that in form y is equal to mx plus c, we have minus y is equal to minus 2x, or y is equal to 2x. Now say for when x is equal to 0, when x is equal to 1, y is equal to 2. So we have the point on the line being 1, 2. Now transforming this point by the transformation matrix, we have the point, you have 1, 2. This is going to give us 2 times 1 is 2, minus 2 is going to give us 0. Minus 1 times 1 is equal to minus 1, plus 2 times 2 is equal to 4, minus 1 plus 4 is equal to 3. So this line is not invariant at all. Now proceeding to the next line, we have x minus y is equal to 0. So that in the form y is equal to mx plus c, we have x is equal to y. Now for a point on the line, then x is equal to 1, y is going to be equal to 1. And transforming this to the transformation matrix, we have x being equal to 1. Now 2 times 1 is 2, minus 1 times 1 is 1, 2 plus 1 is 2 minus 1 is going to give us 1, and minus 1 times 1 is going to give us 1, and 2 times 1 is going to give us 2, minus 1 plus 2 is going to give us 1. So from here we can see that the line remains exactly the same, and we can conclude that the line x minus y is a perfectly invariable line. We can proceed by trying the last line, that is, but from the looks of it is going to be invariant. So we can conclude that the right answer for question 37 is C, which is x minus y being equal to 0. Now question 38, the binary operation star is defined over the set of real numbers as x times y being equal to 2x plus 3y, all that but 7. 5 star 6 is equal to, alright, so our x is 5 and our y is 6. 5 star 6 is equal to 2 times 5, which is 10, plus 6 times 3, which is 18. 10 plus 18 is 28. 28 mod 7 is 0. That's because 28 mod 7, that's 28 divided by 7 is 4 times remainder 0. So 28 mod 7 is 0, which is B for question 38. Now question 39, given the operation table above, the set S or with elements A, B, C, D forms a group under star. The inverse of B is. Now to find the inverse of B, you have to start by finding the identity element. The identity element is an element which, when operated with any other element on the table, the element remains the same. Now looking at this table, we find that if you operate A star A remains A, B star B remains B, C star C remains D, and D star D remains D. So our identity element is A. Now to find the inverse of B, we need to find what element we have to operate B with to get the identity element. Now looking at the line of B, we find out that identity element here A happens when you operate B with B. So the inverse of B is B, which is B for question 39. Now question 40, the set S with elements A, B, C, D forms a group under operation star. A subgroup under this operation star is, for subgroup it needs to be closed. And I'll take for example this expression, we have A and B. It means if you operate A and B under the operation star, all values from the operation should remain A and B, A or B. Now operating A and B under star, we can just start by doing A star A, then go to A star B, B star A, finally B star B. Now A star A gives us B, it is in a set, so it's closed. A star B gives us C, it's no longer in a set, so this expression can no longer form a subgroup. Going with the next expression, we have A and C. A star A is B, is no longer in the set, so this cannot form a subgroup. Now going with C, we have C times C gives us B, is no longer in the set, so this cannot form a subgroup. Now for the last expression, B and D, we have B star B gives us D is in a group, B star D gives us B is in a group, D star B gives us B is in a group, and finally D star D gives us D is in a group. So this last expression forms a subgroup since all the elements under the operation star are in the set B and D. Now question 41, the vector equation of the line segment passing through the points 2, 1 and minus 1, 7 is. Now the vector equation of a line passing through that point R is equal to A plus a parameter, say parameter T, into B minus A, where A is simply the first given point and B is the second given point. So the line is equal to, our first given point is 2, 1, that's 2i plus j, 2i plus j, and our second plus the parameter T into the second point minus the first point. The second point is minus I plus 7j, minus I plus 7j, minus the second point, which is minus 2i minus j. So this is equal to 2i plus j plus t into minus I minus 2i gives us minus 3i, and 7j minus j gives us plus 6j. Now this is the vector equation of the line, and looking at the options, you have 2i plus j plus lambda. In this case, the parameter as lambda, that's plus lambda into minus 3i plus 6j plus lambda into minus 3i plus 6j. We have B as the answer for question 41. Question 42, the vector equation of a line is given by R is equal to I minus 5j plus t into 3i minus 4j. The direction vector of a line is equal to the vector in the brackets of the parameter. In this case, the vector is equal to 3i minus 4j, which is B for question 42. Question 43, P dot Q is equal to, so this is the equation, this is the formula for the equation of an angle between a plane and a line, and the angle between a plane and a line, say, equals theta is equal to P dot Q all over the modulus of P times the modulus of Q. So we have P times the modulus of Q. Alright, so from here we can understand that P dot Q is equal to the modulus of P times the modulus of Q cos theta. So looking at our answers, we have the modulus of P, modulus of Q cos theta, which is D for question 43. Question 44, the vectors A, which is equal to 2pi minus 3j, and B, which is equal to 3i plus 8j, are perpendicular. Then the value of P is, when two vectors are perpendicular, then their dot product is equal to 0. That means 2pi minus 3j dot 3i plus 8j should be equal to 0. So for in that product, we simply multiply like terms, that's the I term by the I term and the j term by the j term. So 2pi times 3i is equal to 6p, that's 6p, and minus 3 times is going to give us minus 24. This should be equal to 0. If you isolate 24, we get 6p is equal to 24, and dividing all through by 6, we get p is equal to 4. Looking at the answers, p is equal to 4, that's A for question 44. Question 45, the y and the x of 5x squared is equal to differentiate this, we bring down the power of x and we reduce the power of x by 1. So this is equal to 2 times 5x, which is equal to 10x, and 2 minus 1 is 1, so that's 10x, which is C for question 45. Question 46 asks us to differentiate cos 5x and we can do this using the chain rule. So let's say we're differentiating cos 5x, and using the chain rule you can say let u be equal to 5x, and this initial what we're supposed to differentiate boils down to cos u. Now the differentiation of cos u, we have negative sine u, and the differentiation of u, we have du on dx is equal to 5. Now from the chain rule we get that d cos 5x on dx is equal to d cos u on du times du on dx on dx. Now differentiating cos u with respect to u, we had negative sine u, so this is equal to negative sine u times du on dx, we had it as 5 times 5. Now negative sine u times 5, we have negative 5 sine u. Another u is equal to 5x, so this is equal to negative 5 sine 5x. That's sine 5x. And negative 5 sine 5x, we have it as option C for question 46. Alright, question 47. The gradient of the tangent to the curve y is equal to x squared plus 2x at the point 1, 0 is. To do this, you have to start by differentiating the equation of the curve, which in this case is x squared plus 2x, and we substitute the values of this point. Now to differentiate this, we start by differentiating x squared, which gives us, we bring down the power of x and we reduce the power of x by 1. That's going to give us 2x, and the differentiation of 2x is equal to x, that's plus x is equal to 2 rather. Now from here we substitute the value of x into the differentiated expression, and the value of x here is 1, so substituting 1 here, we have 2 times 1, which is 2. We have 2 times 1, which is 2, and 2 plus 2 is equal to 4, so this is the gradient. And we have 4 for question 47, which is D. Question 48, the integral of x squared minus 2 dx is equal to, integrating x squared, we bring down, integrating x squared is equal to x all over the power plus 1, and then we increase the power by 1, so this is going to be equal to x cubed on 3 minus, integrating a constant is equal to the constant x, so that's x cubed on 3 minus 2x plus of course the unknown k, so you have x cubed plus 3 minus 2x plus k, which is D for question 48. Question 49, the integral of cos ax dx is equal to, you can do this by saying we're integrating cos ax dx, that's the integral of cos ax dx. We're integrating cos ax dx, and here we have, you can say let u be equal to ax, differentiating u with respect to x, that is du on dx is equal to a, hence dx is equal to 1 on a du, so you can write this as 1 on a du, right? Now we proceed with the integral of cos ax dx. We have that ax is equal to u, so this is going to be equal to the integral of cos u dx, and our dx as you had here was 1 on a du, so this is equal to this is equal to cos u times 1 on u du. Now this is the same as 1 on a into the integral of cos u du. And here finally we integrate cos u du, that gives us sin u. So that the final answer is equal to 1 on a sin u plus k, that's for plus any constant k. And then we understand that u was equal to ax, so this gives us sin u, that's sin ax plus k. 1 on a sin ax plus k. And looking at the options, we have 1 on a sin x plus k, which is C for question 49. Question 50. The area bounded by the curve y is equal to 3x squared and the x-axis in the range 1 b less than equal to x b less than equal to 2 is. To do this, you have to integrate this equation of the curve in the range 1 and 2. In the range from 1 to 2, we're going to integrate 3x squared. The integration of 3x squared is going to be equal to 1 on 2 plus 1 times 3x raised to the power 2 plus 1. So that's going to be 2 plus 1 is equal to 3. 3x cubed on 3 is equal to x cubed. So this is equal to x cubed. And x cubed, we're going to do this in the range of 2 and 1, so that's going to be 2 cubed minus 1 cubed. So 2 cubed is equal to 8 minus 1 cubed is equal to 1, and this is equal to 7. So this is the area bounded by the curve and the x-axis, which is 7, and is B for question 50. So that brings us to the end of this correction of the Cameroon GCE Ordinary Level Additional Mathematics Paper 1 of the year 2025. If you followed us up until this moment, please consider leaving a like and subscribing if you want to see more of this. And you can share this to a friend or a classmate if you find this interesting. Thank you all for watching up until now, and we see you all again in the next one.